Beats are a phenomenon in physics that can be heard when two sounds that have almost identical frequencies but not the exact same frequency are played together. What happens, because one of the sounds is a little bit faster than the other, the two sounds get in and out of phase with each other in alternating periods. Imagine you're walking with somebody who takes just a little bit quicker steps than you. At first, when you start walking, you might be taking your first step at the same time. But because they're faster than you, they will slowly get a full step ahead of you. And then at some point, they'll get a second step ahead of you. And since their walking is a two-step process that's repetitive, once they get to that two steps ahead of you, they'll be lined up with you again. So they slowly get opposite to you and then slowly get back in phase with you or back constructively with you. What that means then is when the two waves are in step with each other, a loud sound is observed, and as they become opposite to one another, the sound destructively interferes and cancels out. And again, when they get back in phase, it gets loud again. And let's take a look at this with an Excel file. Here, what we can see is three functions that I've plotted. This is simply a counter I've made go 0.01, 0.02, so on. This is a sine function whose frequency is given by this 100, so it would be 2 pi f would be 100. And here, 2 pi f would be 95. So 100 and 95. Very similar, but not exactly the same. This column gives the resultant wave that occurs when these two waves interfere. Let's look at the graph here. What we can see, the red wave is this one, the blue wave is this one, and the green wave is the result. Here we can see they're in step with each other, creating a high amplitude wave that makes a loud sound. Here you can see one wave step being slightly faster has caused them to become opposite to one another. Here they've come together again, opposite, together, opposite. And so we get these alternating periods of a loud sound followed by a quiet sound. Let's zoom in here and see if we can see this a little bit more accurately. So first we can see the red and the blue waves line up perfectly and the resulting wave is very large. But the red wave is going just a little bit faster than the blue wave. See, it gets a little further ahead here, and a little further ahead here, and a little further, and so on, until the red wave is almost exactly 1/2 step ahead of the blue wave. And as a result, it ends up completely opposite to it and creating a destructive interference point where the sound is quite quiet. Then the wave starts to catch back up, essentially lapping the first wave, getting back into phase, and creating a large wave again. This variation between loud and quiet in physics is referred to as beats. This really has nothing in common with the way the word is used in music. So again, one wave travels slightly faster than the other, creating alternating periods of constructive and destructive interference. The constructive interference periods are loud, the destructive are quiet. The closer the two frequencies are, the longer it will take them to get out of phase. Or maybe the better way to think about it is the more different they are, the faster they get out of the phase. Either way, the frequency of the beat can be viewed as the difference between the two frequencies. Two frequencies that are very different take less time to get out of phase, and as a result will go through faster periods of alternating loud and quiet. So simply, if we imagined two people in a band playing instruments that were slightly out of tune, 512 hertz and 514 hertz, the beat frequency that would be observed would be 514 hertz minus 512 hertz, or the difference of 2 hertz. It doesn't matter if you consider the F1 to be the initial source to be the 514 or the 512. If we go back to the formula here, we see the absolute value signs that say the beat frequency is the positive difference between the two numbers, regardless of which number is considered first. So that's what beats are. That's why they occur. And we'll do some more problems here where we look at predicting what the frequency of the beat is. Just to be clear here, this 2 hertz means that this sound would get loud and quiet twice in every second.